these different layers, the layer on bottom supports the layer on top. The layer on bottom, or the protocol on bottom, supports the layer or protocol on top. Okay? Think of each layer as an envelope. Okay? Let's talk about the browser, since the browser is the most popular application. Okay? So the browser, someone's on their PC, they're in their browser, they make a request of some kind. What they're doing is making an HTTP request. Okay? At the HTTP level, the formatting begins. Okay? Now, what's happening is something called encapsulation. So you need to write that word down, encapsulation. What's happening here is encapsulation. Okay? The request goes inside of HTTP, the HTTP protocol. Some header information is included, right? The HTTP version and some other things. Right? It goes inside of TCP. Additional header information is included. TCP goes inside of IP. Additional header information is included. IP is responsible for getting the data to its target. TCP is responsible for guaranteeing the connection. HTTP, if there's any encryption or compression, it's going to happen here. Okay? Now back here. IP breaks a block of data down. It says this is too much. I need to break this down into packets. From there it goes to the physical layer. Now it's transporting zeros and ones to a device on the other side, probably a web server, and it unpacks or encapsulates in reverse order. And the protocols on this device communicate with the protocols on the other device. So IP communicates with IP on the other device, TCP communicates with TCP on the other device, etc. Okay. And it unpacks it from a NIC to the IP unpacks the TCP, TCP unpacks the HTTP. Okay. And those protocols are communicating with protocols on the other side. Now, you have to understand, maybe I'm making an assumption here, you all understand what maybe let me take a second and explain. Protocols are a set of instructions for how to communicate. That's basically it. It's a set of instructions for how to communicate. A set of instructions for how to communicate between devices. So, HTTP here can communicate with the corresponding HTTP. You get the idea. TCP with TCP over there, IP with IP over there. So IP unpacks over here, right? Goes to TCP. Like I said, TCP is responsible for guaranteeing the connection. If TCP over here does not get an acknowledgement that data was received, it tries to send it again. After repeated attempts, it will send a message up saying, for instance, your email message failed. Something happened. And you know to send it again. Okay? That's what's meant by I guess, guaranteeing. It's not guaranteeing that the message gets there, but it closes the loop. It guarantees at least you know what happened. At least you get a message back saying, hey, it didn't go. You know to send it again. Okay? Now let's distinguish TCP against UDP. For TCP, think in terms of a phone call, right? I'll call Kale right here. I'll dial him up, phone rings, you hear the phone, he picks it up, he says hello. I can hear him, I say hello. Okay, we've established a connection, we can start talking. Connection-based or connection-oriented protocol, TCP. UDP, connectionless. Think of it in terms of a letter. So I put a stamp on a letter, I go to the mailbox, pop it in the mailbox, and now, at this point, I am relying on the processes of the post office to get my message to the target destination. I have not made a connection with anyone but I am relying on the processes to get it there. Connection list, UDP, connection oriented, TCP. Okay, UDP is used for things like streaming video, sound, things like that, multimedia type activity, where speed is more important. For TCP, reliability and ensuring the connection is the focus. Okay, now, apps layer, OS layer, physical layer. By the way, this layer here is really, on the OSI model, it's considered the transport layer. Transport. And we can talk more about that, later, but let's see. Are there any questions right now? Any questions right now?